Today, we're going to be breaking the ice on concussions in hockey. We'll start with a little background on the brain. Your brain is suspended by cerebrospinal fluid inside the skull. This is what protects the soft tissue of the brain from the hard surface of the skull. A concussion occurs when your head is hit so hard that the cerebrospinal fluid isn't enough to protect it, and your brain hits the skull. This can cause parts of your brain to swell and bruise, which will change how chemicals in your brain tell your body what to do. This is why you may have trouble thinking and moving after a concussion. It's also why, if you've ever tried out for a contact sport like hockey, you may have taken a concussion test. This is so that if doctors think you might have a concussion, they can compare how you're thinking after the impact to how you were thinking before the impact. If doctors find that you have a concussion, they will require you to rest both your body and your brain. Depending on the severity, you will be unable to participate in some activities for a period of time. This rest is super important because some studies estimate that once you have one concussion, you increase your risk to have another one by 3 times. This is primarily due to the chemical changes in your brain that result from a concussion that leave your brain unbalanced and more prone to damage for up to a year. How common are concussions in hockey? One study on concussions in youth ice hockey determined that the rate of concussions was 0.68 per 1,000 athlete exposures. Of these concussions, 47.7% were due to player contact, and another 31.9% were from contact with the glass.
What is biomechanics and how can it help prevent concussions? Biomechanics is how we apply physics to the way humans function and move. Some important physics terms to understand are velocity and acceleration. Velocity is how much something moves in a certain amount of time, and acceleration is how much the velocity changes in a certain amount of time. When you're in a car, let's say you're going 50 miles per hour, that's the velocity. How long it took you to get from 0 miles per hour to 50 miles per hour is the acceleration. In a concussion, the brain starts from rest within the skull. Then once the head is impacted by an external force, the brain's speed increases until it makes contact with the skull. This is the equivalent of your car at a stoplight. When the light is red, you are stopped. Then once it turns green, your car speeds up. If a parent accidentally crashes into another car, your car will stop moving forward and will bounce backwards. This is what happens inside your head when you hit something really hard. Newton's laws of motion are statements that define how things move in reaction to forces. The first law states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted on by an unbalanced force. In concussions, your brain will stay at rest, suspended within your skull until acted on by an external force. When the external force acts on your head, the cerebral fluid will be pushed aside and your brain will accelerate and hit your head. The second law states, if the external forces acting on an object aren't balanced, the acceleration of that object is based on the net force acting on that object and the mass of the object. In hockey, the net force acting on the brain increases directly with the speed of the other player hitting another, or the speed in which the affected player hits the wall.
Finally, the third law states that for every action, there is an equal and opposite reaction. If a collision occurs between two players on the ice, both will be impacted by a force of equal magnitude. However, since the subsequent acceleration due to force is dependent on their mass, their reactive acceleration will differ. Because of this, players with smaller players are more likely to suffer from concussions. In player-to-player collisions, the hitter was on average 1.26 centimeters taller and 3.58 kilograms heavier than the player he concussed, as he was bigger than him. In addition to linear motion, the brain is also impacted in a rotational sense, which leads us into our next topic of basic rotational dynamics. Thus, angular velocity is the rate of change of an object rotating or spinning around a fixed point. Similar to its linear counterpart, angular acceleration describes the rate of change of the angular velocity if an object's speed is not constant. In hockey, if a player is struck by another player or a wall at an angle, their body, and particularly their brain, will experience some degree of rotational motion. Thus, the subsequent force leads to a higher angular acceleration of the brain tissue. While the tissue is mostly unaffected by small accelerations, this rapid increase in rotational speed causes an imbalance of matter in the brain, which leads to a concussion.
Another study performed by researchers at Brigham Young University determined that men's ice hockey had the highest rate of recurrent concussions at 20.1% due to the high level of contact within ice hockey regulation. Recurrent concussions increase the likelihood that the concussive symptoms will persist more long-term. Multiple concussions can add stresses and strains on the brain that are so extreme that the brain cannot return to its original form and functionality. This is analogous to increasing the strain on an object past its elastic limit. This loss of form and functionality can result in longer-term consequences due to the structure and chemical balances of the brain being damaged after undergoing such extreme stresses and strains. These long-term symptoms include persistent sudden mood changes, severe memory loss, and chronic traumatic encephalopathy. Chronic traumatic encephalopathy, or CTE, is a neurodegenerative disease caused by repeated head injuries. CTE has been widely researched in the last decade in respect to professional athletes and the effect it has on their behavior and health later in life. Many athletes with CTE develop symptoms later in life after their athletic career and experience behavioral and mood issues, violence, or dementia.
So in conclusion, your brain is one of the most vital organs of your body. It is important to take the right steps to protect it and yourself from harm or injury. Make sure to wear a helmet when engaging in activities that could lead to head injuries and concussions, like riding a bike or skateboard and playing contact sports. Thank you.